This is a measurement of statures of people in the men in the department of Doubs in the east of France. The main town is Besançon, if you know it. And Edgeworth said he got the data from Bertillon, who was the author of the Bertillon system for identifying people that was later replaced by the fingerprinting system. At any rate, Edgeworth's point was that real distributions are not always normal. And it was quite impressive to be able to print diagrams like that in the middle of text. That was fairly advanced, even if a hand-drawn diagram without scales and a black background is not really very attractive. But if you look at Levasseur's paper in the from the same Jubilee meeting, you find this graphic. And this shows the development of the Swedish population from 1750 to 1875. And that was quite an international effort. It's a paper in French displaying an Italian graphic of Swedish data with Latin annotations. And you might say, well, that's not a very good picture of it. Well, I apologize for that. It was taken in Queen's University Library in 2017, as the PDFs available on the web do not do justice to the full fold-out image. The diagrams must have been printed separately on a large page and then bound individually. It's claimed, Levasseur wrote, on lit très distinctement, in other words, you can read very distinctly, that the total population over time is growing. That's the black line at the back. You can see black lines for age groups. You can see the population age structure at different times, the red lines going from back to front. And you can see, using the blue lines going diagonally from left to right, from back to front, that the survival curves. Now that's a pretty strong claim that you can see all this distinctly, but the quality of the reproduction is extraordinary, and I urge you to go and look for yourselves. The difference in quality between this and the printed version of Edgeworth's graphic is dramatic, and indeed the quality puts to shame much of what is presented to us today. There was one other thing I'd like to say about taking this photograph. It was around exam time when I visited Queen's Library, and it was full of students working on their laptops. I may have been almost the only person present in the library looking at a book. Well, returning to Irish sources, there is this election map from 1895, a simplex chart prepared by Sir John Ross of Bladensburg and published in the Times. Ross's family home was in Rostrevor, which is the Irish connection. The dark constituencies are called the Separatists, that's the old Liberal Party, and the Irish Nationalists, and the light are the Conservatives and Unionists, as I think we might have guessed by looking at the Irish part of the map. Salisbury and the Conservatives and Unionists won the election easily. The constituency right at the very top, if you could zoom in on that, you discover it says in the little box that they haven't declared yet. That's Orkney and Shetlands. It must have been difficult to get the votes in and then pass on the results from there in those days. The Times had published a version of the map some 3 weeks beforehand, just before the election started, with the suggestion that readers should pin it up on the wall at home and colour it in as the results were declared. UK election counting took longer in those days than it does now. And before leaving Ross, it's interesting to note that he was very keen on other things too. In his retirement, he built up what a 1919 article in Irish Gardening called the largest collection of plants growing in the open in the whole country. Sadly, the gardens have not been kept up since Ross's death in 1925, but many trees are apparently still left. Coincidentally, while Ross is associated with Rostrevor, Edgeworth was born in Edgeworthstown. There's a plaque for him in the church there, organised by the Irish Statistical Association, the prime mover being Dennis Kniff, I believe. Well, the next plots I want to show you are by student, William Seeley Gossett. They're part of his superb critique of the large-scale Lanarkshire milk experiment involving 20,000 school children. Look at the telltale step patterns in the weights. The children were weighed dressed, and for the poorer children, that would make less difference between summer and winter. Gossett not only pointed out the flaws in the design and execution of the study, he described how it could have been done much more effectively with fewer children. It's an early example of how to work properly with a large data set, and relevant to today, an example of where careful planning and data collection of a smaller number of cases can be far better than the industrious collection of a large number of cases. The graphics in the 1931 article as a whole deserve close attention by anyone interested in statistics. Well, before getting on to present time, I'd like to look at another set of graphics. These are from a paper by Roy Geary, who was mentioned earlier, another major Irish statistician. It compares rates of mortality in 1949 with those in 1900 for men and women of ages between 15 and 44 for regions of the British Isles. And by the way, notice that the graph on the right has quite a different vertical scale from the one on the left. There is EW for England and Wales, S for Scotland, NI for Northern Ireland, and I for Ireland, meaning the south. Now, these bars are all drawn equally wide, but actually the populations were very different. England and Wales had a population of about 32 million in 1900 and 41 million in 1949, whereas Scotland was round about 4.5 million to 5 million, and Ireland was 4.5 million going down to about 4.4. And it would have been useful to include that information. Notice how Geary places the two Irish rates for 1949 on top of the total rates in 1900. How often have you seen something like that? You can see the general improvement over time, that the rates went down, health improved a great deal, but that figures for the South were sadly relatively bad, especially for women. The whole article is worth reading for its summary of health statistics at the time. We've come a long way since then. They had come a long way from 1900 to 1949. We've come a long way since 1949. And the other thing to note, of course, is that the plots would have been drawn by hand. I don't know by whom. Preparing graphics is much easier nowadays. Well, that was a quick look at the past. I wanted to say something about my own work in graphics. This is display of histograms here. This is the histogram of the divorce referenda rates in 1986 for the Irish constituencies. This is for the divorce referendum in 1995. And over here we have the constituencies. There are no scales because it was interactive software, so you could have just queried anything you wanted to know or queried constituencies or linked from them. The overall results were that in 1986, expectations were confounded and the divorce referendum was voted down by close to 2-1. But in 1995, it was carried by 9,000 votes out of 1.6 million. The idea of drawing statistical graphics interactively linked to polygon maps, this is just a polygon map, was implemented by Graham Wills in his Regard software, which was developed in Trinity in the late 1980s as part of Graham's PhD, working with myself and John Hazlett. What's happened is the top divorce supporting constituencies have been selected in one of the histograms and are shown on the map. And you see a very strong geographical structure, that the outer Dublin constituencies were the strongest supporters of divorce in both referendums. And in fact, if I had an interactive version here and would move along this one of these histograms, you'd see a very striking geographic pattern of where the support for the referendum was. Incidentally, these graphics weren't drawn with regard. They were for the 86 referendum was done that way originally, but these have been drawn with Manet, a later software by another of my students, Heike Hoffmann. And Heike did a lot of work on mosaic plots. And this is an example with an Irish data set, the tragic sinking of the Titanic, showing the survival rates for the classes, first, second, third, and crew, and sex, male and female. And the width is showing how many were in each group. So the width here shows you that the biggest group was the male crew members. And the height of the red bars is showing you the proportion of people who survived in that class. And what we can see here is that for any male group, the rate is always lower than all the female groups. We can see that For the females, the rates went down from first class, second class to third, but in males, you've got this curious pattern: highest survival rate in first class, lower in second, slightly higher in third, and even higher with the crew. Well, of course, you had to have crew going off in every lifeboat, and that will have had some effect, but it's certainly a curious pattern. Now, the two things I'd like to mention here about mosaic plots associated with this example. Firstly, there are innumerable analyses and graphics using the Titanic data set and versions of it. A few are good, many are bad, and quite a lot are just ugly. Yet well-designed mosaic plots do really well. The problem is that mosaic plots are little taught, and when taught, are often taught simplistically without appreciation of the subtleties involved. And that could be said about a lot of graphics teaching. Catherine had already mentioned the artist package. There were actually a group known as the Augsburg Impressionists. Manet was one of them. There was also Turner, Cassatt, Klimt, Renoir, and a few others leading up to Mondrian, although of course he wasn't an impressionist at all. He was the only one who wasn't. And my group investigated and developed interactive graphics to gain impressions of data. Many of the ideas we implemented are relevant now as researchers have become interested in interactive graphics again, although it's more computer scientists than statisticians. Interactive graphics assist you in querying, rearranging, reformatting, and most importantly, linking information. The tools encourage you to investigate graphics and find the information in them. It's not enough to draw a graphic, you have to explore it and discuss it. Have a look at books and articles and see how often graphics are included and not discussed at all. There's doubtless some of that in the two books I co-edited here on the left, The Graphics of Large Data Sets with Heike and Martin Toyce, and The Handbook of Data Visualization. But I hope that the book I wrote on my own on the right, all the graphics are discussed. If you find any that aren't, do let me know. All the graphics are freely available on the web with the code, but the discussions in the book. Well, that's really my present, but what about the future, so to speak? What do you do when you retire? Well, you start writing another book, that goes without saying, and you think of new graphics. This is one I call an overview of outliers plot, or an O3 plot, for comparing outlier methods. The idea was quite simple. If you compare a number of outlier identification methods, they will agree on most outliers and disagree on a few. At least that's what I thought. Turns out not to be like that at all. This example for the 299 German political constituencies using 6 methods is not unusual. 82 of the 299 constituencies are identified to be outliers by between 1 and 5 of the 6 methods. There wasn't even one case where all 6 methods agreed for between 1 and 4 of the variables analyzed. So these columns show which variables are applying to each row, and these are the constituencies, and any cell filled tells you whether that particular constituency was declared to be an outlier or not, and the coloring tells you how many methods declared it to be an outlier for that combination of variables. So normally you'd only be talking about the very last row where you're looking at the full data set of the 4 variables, but I decided it was interesting to look at all sub-combinations as well. What you could do is look at it more positively. Instead of saying it's bad that all the outlier methods disagree, you could say it means that methods are genuinely different because they're finding different outliers. Anyway, if you're curious, have a look at the vignettes that are associated with the R package with that. The next graphic is something I presented at CASI last year. It shows an up and down plot for the Northern Ireland population. The idea was to show both the level of percentage increase, which are the lengths of these bars, but also the absolute changes, which are the areas, because each bar has a width according to the initial population in 2011. Then we draw for instance, for here, this local government district, Armagh City, Banbridge and Craigavon. We draw here's the base population, we draw the percentage increase, then the area of this must be the absolute increase. And what I've done here is I've got the overall increase for Northern Ireland, the red dotted line. I then got the local government districts, and they've been sorted according to the percentage increase. So you can see Armagh City, etc., was the highest percentage increase. Derry City and Strabane was the lowest. And then within each of those, we've got the district electoral areas, the DEAs, and they are shown as well. And they've also been sorted within their LGD, their local government district, by the percentage increase. And you can use a variety of different sortings. But the point is, you can see that all the districts increased in population between 2011 and 2017, all of the blue rectangles up to the right of zero. And there are a few individual, most of the district electoral areas had increases, but there are a few which didn't. And of course, you see that Belfast, not unexpectedly, has the largest height here because it had the largest initial population. There isn't a package on the web. There is a package on the web. It isn't on CRAN at the moment, but if anyone's interested, they can look at that. So you've seen examples from the past, from Edgeworth, Student, and Geary, some examples from my present. And one of the things is that the quality of reproduction of graphics has improved enormously. The only thing that hasn't changed is people have to pay more attention to the content. Nothing much has changed in that respect. You get some beautiful graphics, but then nobody explains their content. They don't discuss them. They don't explore them. But the future for graphics is promising once current enthusiasms have been tempered by a better appreciation of what's been done before. My group did a lot of interactive graphics, but others did as well. For instance, Catherine Hurley at Maynooth, together with their collaborator Wayne Olford, and a lot of what they did too would be useful to modern research. I've been asked to say a few words about CASI's history because I was involved from the beginning, and I'd like to do that because there's some interesting characters involved and interesting stories involved. But let me start with Irish Statisticians and go back to Edgeworth. Now, he's famous and he had nothing to do with our conferences, but in some sense he sets the scene. And he had two important characteristics, one you should follow and one you should not. The one you should follow is that he had many excellent ideas. The one you shouldn't is that he wrote in such a way that no one could follow them. As Stigler says in his 1978 paper on Edgeworth, all investigators of Edgeworth's work must at some point come to grips with his unique style of writing. And in fact, Stigler had a whole section on Edgeworth's style. I'd like to give you an overview of what Edgeworth achieved in statistics, but it's difficult. Stigler's summary was, Edgeworth's influence, his impact upon his contemporaries, and the development of statistics was like his writing, subtle and profound. The subtlety of his work and the difficult and diffuse manner in which he presented it prevented both Edgeworth's contemporaries and posterity from pointing with assurance at his most significant accomplishments, which is a nice way of saying I've no idea how to sum him up. But apparently Edgeworth had a third characteristic one or two of us share with him. I quote, "One of the difficulties in pursuing Edgeworth is his handwriting. Of all those who wrote to Carl Pearson, his hand is one of the worst, ranging from the bad to the horrific." That's Wishart commenting on Stigler's paper. No talk on Irish statisticians can avoid mention of an Englishman, Gossett. What a major contributor to statistics. I don't need to summarize his achievements here, but it is worthy of note that his work was mentioned at the first conference when Tony Vincent, another Englishman who came over to work at Guinness's, claimed that when he arrived in the late 60s, early 70s, he threw out loads of old papers from the office. Afterwards, he wondered if he'd thrown out work of students. Charlie Smith, the Guinness statistician at the time, who was also at the conference, did not seem to give this much credence. And the next Irish statistician I want to talk about a little bit, again closely associated with the first conference in a strange way, is Geary. It appalls me now to think that we did not invite him to the first conference, for he might have come. He was 85, but still active with a vigorous mind and a strong character. He set up the Irish CSO and also what later became the ESRI. He published many excellent papers, and his 1947 paper on testing for normality had the splendid line you see here on the slide. Normality is a myth. There never was and never will be a normal distribution. Well worth remembering, and in line with Edgeworth's example of 1885. I actually met Geary at a talk at the Institute of Advanced Studies, probably in 1981 or round about then, or 82, and accompanied him back across the road to his office. He shuffled along and entertained me with stories from his statistical past, including one in which he set Fisher to rights. If I can't remember the details, it was because I was worried by all the cars whizzing past as we made our slow progress across the road. It didn't seem to bother Geary at all. Another person we didn't invite, but probably should have, was Gordon Foster, then Professor of Statistics at TCD. He'd worked with Turing at Bletchley and afterwards, and was the designer of the ISBN, International Standard Book Number, we all know. But his interests had moved away from statistics by then, and if I may say so, as someone over 70, he seemed so old to us at 60. So who was at the first conference? Well, there was Iggy O'Murchatty, who gave a splendid talk, even if his slides must have been written on the train up from Galway that morning. We all used handwritten slides in those days, and many would look pretty scrappy compared to what are presented today. By the way, does anyone know when the last chalk and talk presentation was given at an Irish statistics conference, or was there ever one? Iggy O'Murchatty went on to become president of Galway, just as Don Barry, also pictured here, whose first talk was at the 4th conference at Castledermot, went on to become president of Limerick. There have been many success stories of participants at our conferences. Another from the very first meeting, already mentioned, was Adrian Raftery. Just look at that citation record. And of course, there's a gossip connection there, as Adrian gave the first gossip lecture in 2014. Before looking at some of the other successes, let's go back to Iggy O'Murchatty. He claimed we twisted his arm at Blessington to organise a second conference in Galway, and maybe there was some truth in that. It may have helped that as we'd invited no guest speakers, we were going to make a healthy profit, and the money was burning a hole in our pockets, as we'd no official organisation. Dennis Kniff and I opened a savings account for it. Anyway, Iggy said he would organise a second conference in Galway if he could invite people, and he invited his brother Colm, the well-known survey statistician, and one of the top statisticians of the day, David Cox, then EMEA 57. David said he would arrive the day before the conference, and Iggy told us he wasn't sure what to do, so he took him to see a John B. Keane play that David enjoyed hugely. Perhaps that's why he's been so ready to return to our conferences over the years, and Iggy's idea of inviting guest speakers has been a huge success. Why was there no organisation initially? The RSS seemed too UK-centred, the Royal Irish Academy was too broad, and in both cases the Royal Prefix was not a plus. We did think of the Social and Statistical Inquiry Society of Ireland, CASI, and Michael Stewart and I stood for election to their committee in 1984. CASI was shocked. There was a rumour that it was the first election there had ever been since they were founded in 1847, and I don't know if there have been any elections since. The CASI stalwarts made much more effort to get the vote out than we did, and so we decided we were not welcome. Getting back to the guest speakers, look at some of the big names over the years. You can see how often David Cox has been. Congratulations to Catherine Hurley for getting Hadley Wickham for next year. He won he was last year's Cox Prize winner at the ASA, the prize for the most important statistician under 40, a very big award. He's actually an academic grandchild of mine, having been co-supervised by Helga Hoffman and Di Cook. You may have seen Crystal Donnelly and David Spiegelhalter on television a few times on television recently in their roles as UK epidemiological experts. There is, of course, Fionn Murtagh for clustering, Trevor Hastie for statistical learning, Andres Bouya for 3D graphics and various other things, Peter Diggle for spatial statistics, Don Rubin, imputation and lots of social statistics stuff, Nelder and McCullough, the important book McCullough and Nelder for GLMs, David Hand, Brian Ripley, loads of people here, and I can't resist picking out Garrett Gulliman because he was supervised by Hadley, so he must be my first academic great-grandchild. One name that strikes me as missing is that of Dennis Lindley, although he did visit Trinity in the early 1980s as Donegal lecturer for a very successful few days. Michael Stewart, one of the initiators and a long-time supporter of the conferences, invited him. Another person who visited Ireland, but not the conference, was Bill Venables. And again, it's a matter of a book, but there's, of course, Venables and Ripley. And Bill gave a course in 2005. Checking my old emails, I discovered he wrote to me at the time, I was expecting the usual 20 or so students, but instead I got an overfull house of 70 people, a kind of informal general meeting of the Irish statistical community. And we had a pretty good day. My memories of statistical meetings in Ireland also involve lots of pretty good days. But what has happened to the participants over the years? I've mentioned Iggy O'Murcady, Don Barry, Adrian Raftery, but look at some of these names. John Murtagh gave the first talk in 1981. He has been, Sally mentioned, he was a colleague of hers at Ulster University. He's been a professor there. He's been a professor at Queen's, at Royal Holloway, at Derby, at Huddersfield. He's worked in Strasbourg. He's worked in Munich. It's hard to think of a place in Europe where Fionn hasn't been active. I moved on to Augsburg. Aidan Moran was professor at Cork at that time, but went on to become registrar. John Hazlett, professor at TCD. Gabrielle Kelly at UCD. Sally McLean, of course, at Ulster. Phil Boland at UCD. Dennis Kniff, ESRI. And you see that all these are fairly early conferences I'm talking about for two reasons. Those are the ones I was mainly at. And also, of course, these people have had time to develop their careers. Gilbert came in 1985. He actually gave 2 papers, so maybe there should be a star against his name there. Finbar O'Sullivan gave his first paper in 1993. By the way, all this stuff depends on my correct reading of the records of the Society. I hope that I've got all the names and dates right. Catherine Hurley's talk, I think, was the first in 97, Del Marshall in 98, Carol Walsh, John Newells. And one name I did wonder about, David Madigan, who did his PhD in Trinity in the mid-80s and has went off to the west coast of America and is now a big wheel in Columbia in statistics, Columbia and New York. I couldn't find him having given a paper at CASI at all, which rather surprised me. And of course, there've been many others over the years. Now, I've concentrated, as I say, on participants from earlier conferences. What will the future bring for participants in more recent years? I look forward to hearing of their progress, and I wish you and them every success.